All right, there we are. Hello again. Make sure everything's lined up. We're all good. Cool. Welcome back. How you doing? Nice to see you once more. Streaming some Haskell action. Here, we've been working on the stream for a while now on an algorithm, learning an algorithm. I've been trying to learn wave function collapse. It's been a journey, learning quite a bit. So the idea behind wave function collapse is an algorithm for procedural texture generation. And there's a couple different variations of it. The one we're working on is probably the hardest one, which uses like an input image as a source, a smaller input image that kind of, you generate your rules from that image. So it kind of breaks it up in little tiles, overlapping tiles, and generates the rules from the overlapping tiles, which ones are allowed to overlap which, and then uses that information and some other information generated from that process to generate a bigger output image that looks similar to the input one. All right. So in the last little while, I attempted to kind of see if I understood the propagation step of the algorithm, which is kind of the final part of it, and implement it on my own in Haskell, which is what we're working in here. We kind of got stuck with it turning into a bit of an infinite loop. So there's a guide from Gridbugs, as a fine person who has done this algorithm as well and learned how to do it. They did it in Rust, so I've been taking some hints from here, trying to learn about the algorithm a bit better, figure out where my understanding of the propagation step went wrong, things like that. So hopefully we can figure it out and get us to the point where we're starting to generate some output images, right? So it kind of ends up looking something like this if you animate the process. Kind of what we're going for. So let's look at the code. Let's get to it. There we are. Yeah, we're gonna go in the source, algorithm, blah, blah, blah. Okay, so the way I originally conceived of this would be like we'd have kind of like a stack. When we go to collapse a cell in the propagate step, we go to collapse a cell, we choose a value for it out of all the potential ones that the cell could be, right? And in so doing, we collapse the number of possibilities that could be in the neighboring cells. And so we have to disable those potential ones. And since we updated those cells and removed some potential ones from those ones, the neighbors of those cells will also have to be updated, so on and so forth, until there's no more updates to do. Right? You've kind of like let the wave collapse. And my original idea for this was kind of like to almost do it in a somewhat recursive way based off of a stack where we would collapse the cell, initialize the stack with all the neighbor removals that we have to do, and put those removals on the stack. And then our propagate step would pop off the stack. That's at line 595 here. Pop a removal off, go to that cell that the removal is for, and remove that potential there. And then proceed with the step of looking at the neighbors, initializing the stack with more removals that we have to do, so on and so forth. However, there's something about this that wasn't quite working because our stack was never getting small enough to the point where it's finishing with our test case, which is supposed to be small enough that it should be able to get to an answer pretty quickly. And it wasn't. So there's something going on there that I was missing out on that I'm trying to figure out by looking at this other implementation and translating it in Haskell to see if I can kind of understand what's going on here between my original idea and what this person implemented. Make sense? Hopefully it makes sense. I think it's a pretty good learning strategy. It's worked for me in the past. Yeah. So, what's up, Apex Twing Tom? Nice, nice. How you doing? Okay, so in that case, I think the step we were on was just about here. We're like updating the removal stack and so on and so forth. So let's look at here. I think it was in putting it all together. No, it was here. Yeah, propagate. So also learning a little bit about Rust as we go along too, reading some of this code. Um, and there's like a couple of weird things in it too. We've noticed like this line here, this opposite direction doesn't get used again. So kind of hoping that this tutorial is right, because I guess the kind of the weakness of this approach is that your source material has to be pretty good. Otherwise it doesn't, you might miss the thing that you need to learn. Look up the count of enablers for this tile. I think that's what we were looking for, right? Let's see. Enabler counts. Neighbor cell pattern enabler counts. Let's look at the command in the printer. Yeah, I think that's this one. And then when not contains zero count, enabler counts. Remove the possibility. And the pattern result. Yeah, okay, that's right. Oh, okay, so we have to do a couple of other things here. We could potentially check for contradiction. If the neighbor cell has no possible tiles to pick from. And if we change the entropy, we have to update the entropy list, which is using a heap here. We're taking actually, I kind of cribbed this from that as well. The entropy list, just a good design there. Really appreciate that one. That's a good tip. The entropy list uses a heap here where you can calculate the entropy of the cell. And the idea of the entropy is that you want to keep basically the cell with the fewest possible choices. You want to pick that one first and collapse that one from all the ones you could collapse in a given step of the algorithm. And because if you do it randomly, I guess the idea, what I understand at least from the algorithm, is that if you do it randomly, there's a higher chance you'll encounter contradiction, which is where there's no solution and we can't finish collapsing all of the cells down to one value. So by choosing the one with the least amount of entropy, is what they call it, or the least number of values to pick, then we do that. So using a heap basically keeps all of your entries in your queue in some kind of orders. They have to be orderable items in there. And you can have like a min heap or max heap. So we use a min heap there as our list, where when we pop off from the top of that list, we always know we have the cell with the least entropy. We don't have to go searching for it every time, which is a cool thing to do. And even this article even has a great tip on it, like how to make sure that you solve for the case where several cells have multiple or have the same entropy. So we add a little bit of randomness into it, so that into the value we sort on in order to do that, which is pretty cool. So that's what this is doing here. We're updating the entropy coordinate for a particular cell and pushing it onto the heap. So yeah, let's do that. Let's figure out what happened to tunes too. Did I lose my internet connection? No, we're still here. The music's dropped out. Apologies. I'm gonna fix that quickly. Let's go. check. Let's go that one. There we go. Okay, entropy list. So they just enter an entropy core. They call neighbor cell.entropy. I'm guessing that's like some kind of member function that recalculates the entropy for that cell? Or the entropy value for that cell. Okay. Or just gets the cell's entropy. It's just a getter, I assume. I wonder if that recalculates anything. I'm gonna assume maybe it's just a getter? I don't know. That seems like a dangerous assumption, but... Okay, so we have to modify... We have to insert there. Build entropy... I'm just wondering about a function for this defined already. It's the entropy list. Add entropy cell. Yeah, see, this is where we do all those calculations there. We get the cell, we get the entropy cells, add a little random noise. And then entropy cells prime, entropy cell, we heap insert. And then we add that back in. So this looks like what we could use there. Probably wouldn't hurt. Add entropy cell. And this is going to be the remove pattern with a compatible pattern. Neighbor cell, neighbor cell. Where does neighbor cell come from? Up here. Okay, neighbor cell, yeah. Neighbor coord is what we need to pass in here. We still have to get the neighbor coord. That's right. There's a hole there. Do. And then add to removal stack. I think it's the last thing. Probably have a function for that as well. If I don't, push removals. Yeah. Push removals. Good. So that one, we need to give it the removal update. And that can take the neighbor coord, I believe. And the index. Which is going to be compatible tile there. And I think we could name it the same here. Compatible tile. Compatible pattern. Compatible pattern. Remove patterns, I call it. Okay. Remove pattern. Cool. That's that. And then leave the contradiction stuff out for now. Just got to fill in this hole here. So, our neighbor coordinate. I think this is probably what they meant by the opposite direction there. To get that coordinate. They probably moved it into this getter here, this function. Or direction. So, I don't think I have a neighbor direction function. So we could probably do that. Probably don't need the type annotation. We implement this. So neighbor for direction would take the removal updates coordinate as its first parameter and the direction. So some coordinate and a direction. Coordinate. I can't remember what I called it. It'll probably give me a type error. That's fine. And direction, dir. Okay. Let's implement that little helper. We got from direction. This one takes the grid. Oh, because we need the array bounds. Right. Because our grid wraps around the poles like a toroid. Next one, direction. What's direction used here? New case on direction. Okay, so that if we get up, for example, we decrease the y. Okay. And it's sort of like this, except we want the kind of opposite of it. I think is what this one is. I'm assuming that only because I don't know if we have an implementation of this function here. I think it's just kind of assumed there. And just kind of given this. See, relative to neighbor cell, the cell at removal update.coord is in the opposite direction to direction. So I think that's what that means. Right, so instead of taking the base direction and the direction up and decreasing y, and getting the cell there, that coordinate, I think we need the coordinate in the opposite direction of up, which would be increasing y. So I'll take that. It's not too hard to just copy and paste this and change the name of it and modify it and see if we're right. Get neighbor, or what was it? Neighbor for direction, I think I call it. Now we still need to do grids, we'll have to pass that in. Coordinate direction, then we get a coordinate back. Just so we can do the toroids bounce checking. So we're going to change this, flip this around. Y plus 1, maybe y minus 1. This will be minus 1 and plus 1 here. Since we increased these, to increase y here, then it's no longer if y is less than 0. We actually want this one. We want them to trade places. And same for the left and right case. Okay, the test suite I think is broken as hell at the moment. Let's get it running so we can just ignore the ones that are broken and we'll fix them later, and write a few for this function, this helper function. Oh, we have to make sure actual code compile in order to do that first. So let's do that. Okay. Bang, 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 bang. This needs a grid. That one's probably not the right name for it.
Savage as hell.
I called it propagate cell X. Of course I did. Bang. Okay, cool. That's good. Now what do we got? Okay, these are the test failures I was mentioning. No problemo. So let's go into I think some of these are going to be pretty easy to fix if we can just get those out of the way. So line 70 here, wave state. Yes, make grid needs one more thing. It needs the adjacency rules. No, but we don't have adjacency rules, y'all. Bam. Yes. Generate the adjacency rules then. So let's pop over the spec. Generate adjacency rules, please. The patterns. From the pattern result. Pattern result patterns. Yep, we're almost there. And then I'm gonna pass in those here. Most of these are similar. So yeah, I'm just gonna go through. we done? Make grid. There and there. Okay, this one is, right, because test grid is the same thing. That should be fixed now. Oh, no, okay, we're good. Yeah, so we just need to disable these two tests here. 019. Oh, exit. Okay, there we go. So let's just quick little one here. From direction, do I have a bunch of those? Yeah. I'm just going to crimp that, change the expectations. Neighbor for direction. That's going to be tricky to do. If I just grab this whole block here. In region, direction to neighbor direction for direction. And we need to pass in the grid as well. So it's just going to be test grid. Oh, it's already there. So just neighbor for direction. Yeah. Okay. So then up no longer wraps around the bottom. I'll flip that around, wraps around the top. I think. So let's focus just on that one test. Okay, just undefined array access. Oh, sorry, neighbor from direction here. No, sorry, we're working on this one. 0, 2, up. And so on the test grid prime, we set cell 0. That should be the dummy cell. Cool. Cell pattern enabler counts. So dummy cell. Cell pattern enabler counts. I think I have a default constructor for that. Just list. It's just a list. Okay. Good. Down wraps around the bottom. So we'll focus on the whole suite now. And just knock them out. There we go. Sound. So right wraps around to the right. Yeah. So we might not be on the left. Alright, we're on the left side of the grid. We're saying anything to the right of. No, we're on the right side of the grid. To the right of. It wraps down to the left. Yeah, 0, 0 should be 0, 0. That's not working. No, that's not it. Yeah, no, this has to be. Yeah. So 2, 0. 2, 0. Yeah. So it is right wrap sound around to right, which sounds weird. So does down wraps around to bottom, now that I'm seeing it. And so this one has to be 2. Let's set at 0, 0. That fixes those ones, and then it's the dummy cell in direction that we test we gotta fix. Yeah. And those are all here. Right, okay, and in direction, we start at 1, 1. set the expected cell direction. Okay. So for up, we expect the dummy cell to be at 1, 2. Right? See if I got that one right. Yeah. Down, we expect to be 1, 0. And right, we expect to be 1, 2. And left, we expect to be 0, 1. Sorry, 2, 1. No. So if I am going right, I'm actually taking the opposite of that. I'm going the left side from 1, 1. So this should be 0, 1. And this should be 1, 2. Sorry, 2, 1. We're talking about the x-axis, not the y. Silly me. There we go. Okay, take the focus off. Make a commit. Let's just check our code here. Alright, so let's see. Neighbor chord, we remove the hole there. We get the grid out of the state, and we use our new neighbor for direction function to get the neighbor coordinate. For the neighbor we're talking about. Remove these to-dos with the actuals, except for contradiction, that's fine. And then we add our neighbor for direction function, which we add the spec for here. And fix a few things in there. That looks good. Let's commit it. Bang. Also add the rest of the propagation step. Okay. The last thing is updating the enabler counts. That is outside of that. Okay, so this in bi-direction equals 1 in there. So we got one extra check here. Alright, so if the enabler counts by direction, I'm not sure what this comment, so we're about to decrement this to 0. So we only do this stuff when this is true. And in any case, we decrement. So why don't we just combine these two together here? something and that. So enable accounts for direction. More like, it's almost like this expression is almost like has enable accounts for direction, or has enable accounts. That's what I'm going to call it. Has enable accounts. I'm going to give it the enable accounts and the direction. Not contain zero counts. And we modify this, we do this stuff. At the end, decrement. Neighbor counts. For direction. And enabler counts. Now this is mutating enabler counts, I'm assuming here. Yeah, and mute. So we have to do something about that. Leave that. Enabler count. Yeah. We have to implement contain zero count and has enabler counts. Direction. Ooh. Extra T in there. Beep. Sorry. My bad. My bad. Alrighty, dinner. Has enable accounts. Now we just have to implement this. Okay. Enable account direction. Bring it down. Bring it down. Get rid of those arrows. Okay, now we're down. Now our hole's down to a single value. Cool. So if we look at the pattern, the enable account type, it is an array int. So the indices into this array are the directions as an enum, if I remember correctly. Yeah. There. To length of directions 0. Okay. Yeah, I think that's what it's supposed to be. So if I get my up and scope, wow. Doesn't want to because it can't compile right now. Oh, enable counts as the list, isn't it? Or yeah, I think it's a list. Oops. No, it should be just a one. Better. Okay. Missing a do. Simple stuff like that. Okay. So up. To enum up. Oh, from enum is the one I want. 0. Right. Okay, down. Left. 3. Yeah, those are all valid indices. So what we want to do is look at the enabler count array, index into it, compare it to 0. Get the thing and check if it's 1, I think is what they were doing in their code here. Yeah, but we could actually just return that and do the check. Get enabler count. That's what I'll do. Get enabler count. For direction. Right. Oh, we can't do it quite this way. Sorry, I was trying to do it. Haskell problems. I was trying to do a point free. It's kind of what I default to in my brain. I'm gonna pull it out this way. Pattern match on it. Getting too clever. Okay, because that way then we can just get the. It's just the array indexing into enable count. With it was from enum direction. Enabler count, not account. Oh. Okay, pop over there. Enabler counts. Get enabler counts. Mm-hmm. Oh, Probably messed up the type signature. Boom. Count. Contains 0 count. We have to implement that. So I guess that's if any value in the counts array is 0. We'll pattern match that out again. Try to be consistent. Consistently inconsistent. And we want to take any, so data.array is our module for this. I think we can get the association list. We know how to do that. I wonder if I could just get the list of values, the elements of the array, list elements in array index order. That's perfect. Enabler count, enabler count, enabler count, enabler count. Sheesh. Okay. And then we want this to be any is 0 or any equals 0. That should compile. Perfect. We're just a little over the edge there, so let's just bring it in. Okay, let's commit that. Okay, looks good. When this commit is added, when applied, this commit will add a get enabler count used to check for condition for and propagate before updating neighbor cell counts. Something like that. Hopefully that's truthful. And then I think one last thing was we needed to decrement the counts for that cell and propagate. So instead of mutating the decrement enabler counts, we got the enabler counts in the neighborhood cell. So we have to use our modify cell to put we have to use our state functions to modify it. Can't just mutate things here. This isn't ST. It's state monad. You can mutate things in Haskell. You just have to be way more explicit than even Rust. Using something called the ST monad, which is pretty cool. Or not. I don't know. And maybe it's a pain in the butt. I haven't done a whole lot with ST yet. Okay, so modify cell at. Maybe that one needs a few things. It needs a coordinate board. Needs a function. And then that's it. Oh, yeah, function. Which takes the cell and either strings. Oh, okay. And that's going to need the direction. All right, so I'm just going to grab that type. I'm going to define that function. I don't think we're going to need these anymore. Oh, almost did. Enabler counts. Oh, that's what the line is. I already had it in there. But it's got to be like this. I think we're going to need it for the direction, right? Yeah. And we have a function for decrement direction. And so we get a new pattern enabler count back for that, which is what we want to put into the cell when we modify the cell here. Do that cell prompt as cell such that cell pattern enabler count is equal to decrement direction. I'm gonna need the enabler counts. We could just return right cell prom. Oh. Why do I have a list of enabler count there? That's a good question. That's probably the way it was set up here. Let's see. Yeah, a vector of tile enabler count. Or a tile index. Okay. So we're gonna need the pattern index as well. And we need the pattern index so that we know which one in the list to update. And since we did it as a list, I think data.list has a way to index into them. It's not super safe, but or efficient because it's a linked list, but it's a small list for this mostly, at least for now. At least for this test one. We can make it more efficient later. We may have to. Yeah, so that's fine. But we just want to what am I thinking here? I'm thinking of I do have to do the updates on the cell pattern enable accounts. Yank that there. Cell pattern enable accounts. Stop bang bang. Oh, that's the lookup. Ooh, we might have to. We might have to. I don't think that function that I'm thinking of, a setter for a place in a list at a particular index, is there. You can look up by the index. Probably never use it, which is why I'm not having to look it up here, if it exists. What do we call update? That. Oh. Yeah, why would even, yeah, it doesn't, it's not a thing. Okay, we're gonna have to fix that in order to do and be able to implement this. Leave that hole there. We'll go over to our cell. And we'll have to change this to an array. Pattern enable accounts. Probably going to break a few things, so let's get back to compiling as quick as we can, at least back down to the hole. Return array. So then we can do list array as long as we know the bounds. We have to give the bounds. It's going to be from 0 to we'll go P up to pattern result max index. And then for each of those, we need an account. So yeah, maybe that. That equation is getting a little ugly to look at. Okay, next. So this isn't going to work anymore. Yep. Okay, and this one is index, pattern count, actual cell, extra cell. There. Oh, that's it. Can match type pattern name account with int. Oh, because I'm not passing in the pattern index here. That'll be compatible pattern. Go back down to this whole. I think nothing else. Yeah. Okay. So now. Cell pattern enable accounts. We want to do the array update syntax for the pattern X and the value we want to give in, which was our decrement there. Bring it over here. A little wide, but it's just gonna have to be that way, I guess. Okay, yeah, we're almost there. Just some broken test code now, but otherwise this module will compiles. It's just one liner. It's on 210. Can we give the empty array? We do it 0. 0, 0 is an array of one element. I think 0, -1 you can do it. Yeah. It's never accessed anyway, so even if we got it, even though it's wrong, it won't do anything. Okay, and those are 2 pending tests. Okay. Okay, so what does this mean? Let's check that in. When this commit is applied, it will propagate, decrement the neighbor cells, enable account. That's initializing the tile enable accounts. I need to implement that next. Sweet. All right. Oh, looks like we didn't need that, so let's remove that. Okay. Oof, we did. We need to implement it. Okay, yeah. Modify cell, remove pattern from cell. That is... Here, yeah. Remove the possibility. No problem. Let's implement that quickly. Okay, so... And we're going to just return right the cell such that cell possibilities cell dot cell possibilities with our array update syntax. Need the pattern index. And we set it to false. Gadoosh. Alright, let's commit that too. This will implement remove pattern. Well, yeah, let me check for any more things I've left undefined. Haven't. Good. Okay. Initialize table things. I'm gonna check that out. No, we did. Okay, makes patterns to cell name. Okay. Okay, that's all done. Then check, check, check. Okay, if that's all put together now, let's go over the spec. And just focus on runwave. Okay. We did hit an undefined array element. We've indexed outside of it. Let's see, let's just double check. We've got everything set up properly, but I think somewhere in the propagate step. I think I know which one it is, but input texture from list 4. So this is the input, like, to the algorithm. Like I said, like a smaller image. And we're taking this example here, this texture from list, to generate like a texture. It's kind of our own internal representation of like a texture with some pixel data in it. And that, print that example from actually one of these up here, this, something like this one. This one here. You see, like, it's kind of a binary image here. You got 0 or 1, on or off. So it's a 4x4. So this 4 should be 4 elements this way, 4 elements long, which looks like it is. So the pattern result, that init wave state. So this is the output size we want, a 10 by 10 output texture with our seed and our pattern result. Then we run our function run wave, which takes our initial wave state and collapses it. Collapse wave. And we should get a final state. Okay, but we are running into an array indexing problem, which I think is in propagate, because we do a few of those. Okay, so it could be enabler counts if that is not set up initialized properly. Let me go to get indexed into with compatible patterns. I think that might be the one. And I'm just gonna trace out the compatible pattern we're using as an index. And if it's showable, we might as well try the neighbor cell pattern enabler counts that we're indexing into. In case I'm wrong about that, I'm just going to put after enable counts. Oh, I got the focus still in there. Other focuses. I do. Okay, so it might actually be before. We could be neighbor cell. Get neighbor for direction. Well, we did all the tests for that one. That shouldn't be it. It could be completely not in propagate somewhere else, but try, yeah. Get there, get at least as far as there. It could be this one, maybe? Depending on what's in remove pattern propagate cell index. Move that up here. And do something here. Pa-pa. 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 A little comma there. A little show action here for direction. We'll check this one out. Let's see where we get that. Okay, so we're in our grid. We go to start 1, 3. We go up. Okay, let's make sure we're actually, this is where it's actually happening. And we get to after, okay. So actually let's show the neighbor chord we get for that. Which, given our tests, if we do 1, 3 up, we should be getting 1, 4 as our neighbor chord. I think 1, 4. And I think that would be an out of bounds access. Yeah. So I don't think we're going to get to here. Oh no. What is happening? If I try to show... Yeah. Yeah, okay. Yeah, so if you try and show it there, on the side we don't get to whoop here. Okay. So it is get sell out. 1, 4 is outside of the index of our thing. So this isn't right. So let's update our spec for it with our new information. This is the, yeah, right browser, right? Should all get bounds. Neighbor for direction. We have to make sure our test grid matches. This 4x4, okay. Just like our other one. Okay. And the other one in being the other one in Runwave. And we try 1, 3, and up. Now we should be able to set the dummy cell at 1, 0. It's because it should wrap around. We go cell at cell from direction. Test grid prime should be cell at 1, 0. Let's make it there. Test grid prime. That's probably going to fail with our runtime error that we have right now in the other test. So I'm just going to turn that other test off. Focus on this one. Just this one, please. So it is working. Not always working. This should make it fail. Yeah. What is happening here? Enable accounts. Enable accounts. No, it's more up here. Yeah. It's got to be that. Let me bring that test back in action. So we get 1, 4. That's out of bounds. Okay, that's out of bounds for our test case, not necessarily for this grid. The grid is bigger, that's right. I don't know why I didn't think of that. Okay, so 1, 4 is not necessarily out of bounds here. As long as the grid size, just to double sure, but I'm pretty sure that's true. Grid. gotta have a grid size balance function. Okay, well I can get the array bounds for the grid anyway. Okay. Get grid cells. We do array dot bounds. Get cells. Let's just get cells. Okay, let's check it out. Let's see what we get. Yeah, so that should be fine. One four is in range. Okay, let's check compatible pattern. Well, that is, or actually, Start 1 3 up after 1 4 2. Okay, and if we comment out that one debug trace line, we don't force the evaluation of that thing. Do we get there? No, we don't. That's weird. Yeah, that should be safe. Okay. Should expect to see you get up here. Get that one, get Okay, and I'm not getting to any of them. Oh, okay. Could be in this compatible function, maybe? It's definitely, it's gotta be for some reason. Gotta be the neighbor cell. Get cell that. Yeah. Okay. Gotta start looking in there. I'm not hitting that branch. So we gotta be jumping into cell at. Otherwise, we'd be getting here. And we'd be able to show this. I don't think we're getting there. Okay, cell at, bang, bang. Get the cells of the grid. We call maybe at cell X. Okay, there we are. That, I'm pretty sure is fine. It might be maybe at. I'm just going to show the index we're looking for here. And that should give us, I think we're getting close here. It's kind of like one of the annoying things about working with arrays in Haskell is that these accesses are runtime errors, like exceptions, which is no bueno. Not super happy about that. So, actually, outside of like some of the projects we've done on the stream, I don't use this module all the time. I want to sometimes though. It's like I know the size of the thing, so I don't really need a vector. So you got bounds, you got indices. Like you got some pretty nice little functions here. It's not a huge module. And I think maybe that might be our problem here. I wanted to implement like kind of a safe lookup, array lookup function. So we're start cell at 1, 3. That's the index we're looking for. Okay. Let's jump down to maybe at. We're gonna go maybe at in range. Because there's an array access right there. Yeah, we get to in range. Okay. And then, so we do the bounds check. So this access should be safe. Let's break this up a little bit just to... Do I break this up a little bit? I'm gonna put a pin in that one and come back to that in a second. Jump back here. And make this a do. Combine that and show the results, and then here results. If I'm allowed to do that. Oh, sorry, not trace on characters. Okay, there we go. That's what I want. Beep, beep. Okay. Okay, it's gotta be that. That's gotta be what it is. Weird, but learning something new. Okay. Learning something new about the array package. Okay, so even though we get to this branch, we check in range for X. We're still getting a runtime error with that array lookup. Where's that in range function coming from? It's coming from data.x in range. Defined by the bounding pair. So we give that tuple here by taking the bounds of the array and index. why does that not mean that the subscript is actually in the array? That's weird. So it's a type class. Okay, it's a type class, so the array has to implement that. I. Okay, so just the indices of the array, looks like. So I'm still kind of blown here. 1, 3 isn't in range. All right, we need more information here. Can I show the array maybe? This might be pretty big. Show the array elements. Right. Let's add the show constraint. We don't even get there anymore? What's going on now? What is happening now? Yeah. Yeah, if this comes back, with maybe in range of the debug output, maybe it means the array that's getting passed in is the problem. Maybe at in range, yeah. I'm gonna use a little do trick here again. Break this up a little bit. Okay. Okay, so this has to evaluate to true in order for us to even get here. So I'm going to just put a debug.trace in here just in case. But I don't think we'll see anything here. Okay. So let's show that. Just the X, just because. And we'll show the array bounds. I'm curious. Okay, we don't know that we should be showing showable. Show for I. So even the array reports its bounds there. 0, 0 to 9, 9. So 1, 3 should be in there. Let's show X. Pure X. Just mutilate this function. Find out what's going on here. We need show E. Yeah, no. For crying out, that is so weird. So weird. Okay, let's try out a few little tests at the REPL here. Okay, so let's make X equal to be array list array from 0, 0 to I don't know 1, 1. Okay, so that's got to be there's gonna be 2 elements. C and D. Right, okay. Oh. No, I defined the very wrong. 0, 0, so we'd have 0, 0, 0, 1, if it's inclusive. 0, 0, 1, 0. And then 0, 1. Yeah, the pairs, right? Or if it's not inclusive. Ba-da-ba-da-boom. Yeah, so of length 10, so from 1 to 10, that has to be inclusive. Oh, sorry, I'm getting it wrong. It's supposed to be tuples. There. Yeah, it's right about the dimensions. That, 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 Q, Q. Almost, yeah, I was right. We don't need the E yet. Let's just be 2. Like that. No? Oh my gosh. Clearly this must be the source of the error. It's like dirt. List of associations. There. 0, 1. Oh boy. B. 1, 1. C. Oh, sorry, 1, 0. Uh, 0, 1. And then 1, 1. B. There we go. Okay. That's how that should be. So we get the bounds of x. We get 0, 0 to 1, 1. And if we add the module data.x and we get in range, and then we get the bounds of x, and we check 0, 1. Oh, I forget. Plus data.x and the array. Right, true. Good. Which means we should be able to get x bang 0, 1. Should be that. There we go, 1, 0. Let's see. Try to get 2, 0. That would be an array index. Error in array index. Exception. Okay. Undefined array element. That's different, actually. Undefined array element. That means we haven't initialized an array properly. Oh, this whole time. Oh my gosh, I was looking at the wrong thing again. I thought it was an indexing issue. And I should have saw it when we printed out the array and there was nothing. The array has the bounds, there's just nothing initialized in it. And we go all the way back to propagate here. We go to enabler counts. I bet in the test, in the spec, or no, it should be setting up everything. So, but something isn't initializing the array to the right thing. Given that all that stuff I just did at the REPL there and trying to get the array initialized, I'm wondering if it's maybe the enabler counts. Because this needs to be the tuples. Yeah, they found it. Or this has to be the index in the array that we want. And this is... I'm not sure why I wouldn't have gotten a type error for that, though. Does a type alias there maybe make it an issue? I put 0 there, for example. Like this dumb, but... I should give a pattern enabler account. Yeah. Bounds. Come on, we're so close. It's gotta be... what if I just change this to int? And I know it's... Is it the type alias thing that's making you trip up here? You expected a type pattern enabler count. That can't be right. Type of list array should be list of ease. Why, was I getting all tripped up on? them being pairs. Oh, because I was using the array constructor? Dang, I thought I had it. I mean, that is the error, though. Oh, this array. We have to give each of the indices for it as tuples. What is the type of X? Okay. No, I didn't have it. Yeah, if I think of the type here. Okay. Let's make X an array of int to int of char. Yes, set to middle scope type variables with that. X scoped type variables. Okay. And okay. So that's more what I was thinking. 0, 0 to 1, 1. Full list, ABC. Okay, so we do only need to give the things in init and pattern counts. Okay, so we don't need this. It's right. Yeah, okay. Pattern result max index. That could be the thing. That could be the thing. Okay. Trace here. Whatever, show pattern result max index. So that should be 15. Okay, so this should be up to 15. So she gets 0 to 14 with the initialized pattern enabler count. All these counts. Well, unfortunately, I'm running out of time for this week, so we're gonna have to finish this next week. It should be somewhere in here. So I'm gonna mark this commit as work in progress. Debugging, getting cell stuff. Okay. And then hopefully once we get that all sorted out, we should be pretty close to done. And hopefully that test will start passing. Okay, let's just make sure our commits are looking okay. I think that's pretty good. Except for the work in progress, but what can you do? Push those up. All right, thanks again for watching, friends. If this is your first time tuning in, thanks for watching. Welcome. I'm Agent Ultra. It's been a pleasure. All the code you've seen tonight for this project is up on my GitHub at Agent Ultra under Wave Function Collapse. I usually do these streams once a week on Tuesday evenings at about 10 after 8 in the evening. So if you want to write that down and just show up, that's cool. If you want to give us a follow, that'd be great. Oh, thanks, Swarm Collective. I didn't even know you're here. That's awesome. Yeah, so you can, if you're give us a follow, turn your notifications, you get notified when I go online, or don't, whatever. And if you're watching on YouTube, because I back up on my streams on YouTube there, you know what to do. You can like and subscribe, hit that like button or whatever, and leave a comment, whatever, you know, all that stuff. Helps the visibilities and whatnot with the algorithms. You can also follow me on the social web here. I'm on the types.pl server in the Mastodon universe. Hey, Goku. Thanks for tuning in. Thanks for watching. It's been a pleasure. What's up, Wizard Stick? Love to see you. So yeah, don't worry if you missed it. If you want to catch up, you can go to my YouTube channel. It's right here. There's the link on my social. Visit me on the types.pl server. Check it out on Mastodon. You got all the links there. And follow along there. The link above my head goes to declarative.tv, and that's a little website that tracks other cool streamers who are doing programming streams in other declarative style languages like Haskell, but others as well. And there's a Discord server as well. So there's a channel on the Discord server for this stream that you can go there. We could chat between streams and talk about your projects, or if there's any questions you had that you didn't want to bring up on stream or whatever, bring them up there too. Let's see. Yeah, I think that's about it. So, except for next week, I'm on vacation next week, but I'll be back the week after. Let's go find someone to raid. Is anybody online to raid? I feel like we should do this and be a good streamer here. ASMR programming, no talking from Programmer Live. Sounds cool. All right, we're gonna go for it. Thanks again, everybody. It's been a wonderful pleasure, and I will see you in September. So give this person a follow and all that jazz.